This is the foldable for section 5.1. We're going to fold it in this way towards the center. And what we're looking at today, let me write that on here, 5.1, is perpendicular bisectors. What that means is that we're going to be working with right angles. Because of the word perpendicular, it means that we have to make things at 90 degrees. And congruent segments. Or congruent sides, because once we make a perpendicular bisector, let me highlight just one of them. We made it at 90 degrees. Making it perpendicular, and that means that this segment will be equal to this segment. Where all of the perpendiculars, bisectors meet, where the perpendiculars, bisectors meet, it's called the circumcenter. So this right here would be the circumcenter of this triangle. Let's take a look inside. This is what test questions would look like. We have point D is the circumcenter of the triangle ABC. So let me just highlight one again. And what we're looking at is that it's at 90 degrees because it's a perpendicular bisector. Means that cuts the section in half. And if we're looking at the segment BE, that would be congruent to the segment EA. The segment AF would be congruent to the segment CF, or FC. And then CG would be congruent to the segment GB. The distance from the circumcenter to the vertex is congruent. So here is your circumcenter, now where all the perpendiculars, bisectors meet, and to a vertex. So I'm going to highlight this. I'm going to make it a much noticeable line. And to tell you that this would be congruent to this. And is congruent to this. So these three segments are congruent. That means that AD is congruent to the segment BD and is congruent to the segment CD. The congruent triangles are congruent AED. AED. So I'm going to shade it in. And that is congruent to the triangle BED. Sorry. BED. I want you to notice that we went to a vertex, to the same letter E, to the same letter D, and they're all pretty much going to go the same way. And so these two triangles are equal. Now I got triangle AFD, AFD. And that's congruent to the triangle CFD. I also want you to notice that this triangle over here, the one that I shaded more, is not similar nor equal to the one over here on this side. So this triangle has nothing to do with this triangle. And then triangle BGD is congruent to the triangle CGD. Now we're going to draw some circumcenters. The circumcenter for this one. So don't forget, what you're trying to do is go to the middle of the segment and then just go perpendicular. How do you draw a perpendicular line? Is that you make your ruler line up with one of the lines of the side of the triangle, and you make it at 90 degrees. So again, you try to find the middle because it's a bisector, and then you try to make it at 90 degrees, and this side is easier to tell. You're making the side of the ruler line up with the side of the triangle, and you're just going at 90 degrees. And it does bisect. So you go to the middle of the triangle at 90 degrees. And then this would be your circumcenter. So for an acute triangle, it's always on the inside. Let's draw one for a right angle. So we have it at the middle at 90 degrees, and it's easier to tell from here because we line up the segment of the ruler to the side of the triangle, and then just make the dotted line so towards the center at 90 degrees. And this one was supposed to land right on the side. So I messed up just a little bit. We'll make it a bigger dot so it looks like the circumcenter landed on the side of the triangle. Because when it's a right triangle, it's supposed to land on the side of the triangle. So for the obtuse, what we try to do is find the middle, go at 90 degrees. That means a bisect and is perpendicular. Do it again for the other side. And you line up your ruler. So this one needs to go a little bit higher. We'll do it again. Line up with the middle at 90 degrees. And this would be your circumcenter. So that's how you find circumcenter. It is the perpendicular bisectors. Let's take a look at the other one. We have angle bisectors on this one. Angle bisectors means that you're dealing with congruent angles. And let me highlight one so it's easier to understand. So you're just cutting the angle this time. It's not really concerned with the bases or the sides of the triangle. You're looking at just the angle, the vertex. That means that is equal to that. Where all the angle bisectors meet is called the incenter. Where all the angle bisectors meet is called the incenter. So this right here would be your incenter. All right, so we have point D is the incenter of the triangle ABC. That means that the angle EAD, that's this one right here, would be congruent to the angle FAD. FAD. Just like I've mentioned before, look at the other letters and they should line up to indicate the correct angle. So that means this one right here. And then we have FCD, that's this one right here. It's going to be congruent to the angle I'm going to say GCD. GCD. And that's this angle right here. Well, now I have angle GBD, which is this one right here. And that's going to be congruent to the angle EBD. EBD. So for this one, it says the perpendicular distance from the in-center to the side is congruent. What does that mean? That means that this is our in-center, and the reason that that was our in-center is because it was created by angle bisectors. And you get your ruler from this, you line up your ruler, so these segments line up over here, and you go straight to the side. Let me flip this ruler around because those inches markings are easier to read. So if you can tell that the line lines up on the side of the triangle, you go to the in-center. I'm going to make it thicker just like we did on the previous one, and I'm going to call this one H. And that's the perpendicular distance. And then we're going to do it again for this side. When you're trying to line up your ruler to the side of the triangle, and then go to the in-center. And we're going to call that one HI. And then for the other side, you line up the ruler to the side of the triangle and go to the in-center. And all of these segments are equal. That means that HD, the segment HD, is congruent to the segment DI. It's congruent to the segment DG. All right, let's draw some in-centers. In-center is always going to be in the interior of a triangle. And what you're trying to do is cut the angles. So what helps me out is that if I sketch, what we're supposed to do is get a protractor and measure the actual middle of the angles. We're just going to sketch it. And that's bisecting all the angles. So this would be your in-center. So it really helps me if I kind of sketch where I would want my line to go. What looks like would be half of the angle. And then I draw the dotted line. And then the point of intersection is called the in-center. Okay, for the last one, what I'm trying to do is just make a sketch of where my line needs to go. It helps me because I can't see the angle very well once I put my ruler on top. And I kind of missed it. Let's make a big old dot as that's the in-center. Okay, and that's the section 5.1.